In this example, I'm going to solve this equation, and I'm going to do it by factoring. So here we have negative 8q cubed, which is pretty fun to say, and then minus 38q squared, which is not quite as fun to say, and that equals negative 10q. And yep, that's how I write my q's. Anyway, so if we're going to solve this by factoring, I need to get all the terms on one side of the equation, and it needs to be equal to 0. So here I see my highest degree term is negative 8q cubed, and he's negative, so probably let's move everything to the right side so I can have my leading term be positive. So when I move the negative 8 and the negative 38 over, they'll both be positive. So 0 equals, and then we'll have 8q cubed plus 38q squared, and then minus 10q. So the first thing I look for always is a greatest common factor, and it looks like I can take a 2q out of the expression. So when I do that, it looks like 4q squared plus 19q minus 5. So this is a quadratic trinomial, and it looks like my leading coefficient is not 1. So I'm going to go ahead and use the AC method. So 4 times negative 5 is negative 20. So I'm looking for factors of negative 20 that add to positive 19. Well, if they multiply to make a negative, I know I have to have one of each sign, one positive, one negative. And if they add to make a positive, then the larger is positive and the smaller is the negative. So let's talk about factors of 20. So 1 and 20, and I don't think we need to go any further than that because that's the factor pair that we need. Positive 20 and negative 1 do add up to 19. So let's go ahead and take that middle term, the linear term there, we'll split him up. So we have 4q squared plus 20q minus q minus 5. And at this point we can do our factor by grouping, because that's the AC method, how that works. So I have the 2q, and this first pair, it looks like I can factor a 4q out of it. So once we take the 4q out, I'll have, what, q plus 5. And our second pair, well, negative q and negative 5, it looks like I'm taking a negative 1 out. So make sure you put this negative and the 1 there. And the leftovers, well, q plus 5. So it looks like these are the same, and that's what we want. So let's go ahead and build our factorization now. So 2q, and then this q plus 5 can factor out. And we're left with these greatest common factors, so 4q minus 1. Okay, well we have 1, 2, 3 factors that I'm going to multiply together to get 0. So our 0 property of multiplication says that if I'm multiplying these and I get 0, well, at least one of these has to be 0. So I'm going to account for all of them, and I'm going to say 2q equals 0, q plus 5 equals 0, 4q minus 1 equals 0. And I'm just going to go ahead and solve each of these equations independently. So I can divide both sides by 2, and q equals 0. That's my first value. I can subtract 5, and I get q equals negative 5. That's going to be my second value. And if I add 1 here, I'll have 4q equals 1, and then I can divide by 4, and q will equal positive 1/4. And that will be my third value. So let's write them all together. Q equals 0, negative 5, and positive 1/4. So here are the 3 solutions then for my initial equation. And I found these solutions by factoring. So here we go.